de Moivre's theorem and related application. It's a vast topic. We learn all those applications also one by one, step by step. So we are going to do de Moivre's theorem. What is that? You just consider this equation cos theta, this expression cos theta plus I sin theta to the power n, where n belongs to n. Okay? We are able to prove that for n belongs to n, it can be shown that cos theta plus I sin theta to the power n equal to cos n theta plus I sin n theta. Okay? This is the concept. So how to prove this one? I'll show you the proof also. For n equal to 1, left hand side cos theta plus I sin theta to the power 1. If index is 1, this we can write cos theta plus I sin theta, which is nothing but cos 1 into theta I sin 1 into theta. Therefore, if you say this one theorem and you are going to prove with the help of mathematical induction, then the basic step for n equal to 1 it is done. Therefore, the relation, which relation? This one. The relation is true for n equal to 1. In mathematical induction, what we do, we assume that the formula be true for n equal to an arbitrary positive integer, something like k, m, whatever you take. So we are going for that, and this part is known as the basic step of induction. Basic step means it is true for n equal to 1. Now let the theorem be true for n equal to k, where k is an integer. That is cos theta plus I sin theta to the power k cos k theta plus I sin k theta, this be true. Okay? Now we are going to prove that it is true for k plus 1 also. By assuming this thing, let this be true, means the theorem we are assuming, let it be true for n equal to k. Now cos theta plus I sin theta to the power k plus 1 is what? Cos theta plus I sin theta to the power k okay. Now this result, what we have assumed, that we can put. So this is going to be cos k theta I sin k theta, this multiplied by cos theta plus I sin theta. Just open the bracket. This is going to be cos k theta cos theta, I square is minus 1, sin k theta sin theta I into sin k theta cos k theta, this multiplied by sin theta. I've just opened the bracket. So therefore cos theta plus I sin theta to the power k plus 1 is, this one is what? Cos k plus 1 theta, and this one I sin
k plus 1.
Yes. So therefore the theorem is true for n equal to k plus 1 also when it is assumed to be true for n equal to k, and this completes the induction, because you have proved that true for n equal to 1, so it will be true for n equal to 1 plus 1, that is 2, n equal to 2 plus 1, that is 3, and so on. So therefore it is true for n belongs to, for all n belongs to n. So if it is a positive integer, then this formula is true, this theorem is true. Theorem, why? Because it is a proof, and direct mathematical proof is possible. That's why it is de Moivre's theorem. Now we are going to consider this case when n is a negative integer. Is it true if it is a negative integer? Let us check. Let n equal to minus m when m greater than 0. So n going to be negative. Therefore cos theta plus I sin theta to the power n will be I sin theta to the power minus m cos theta plus I sin theta to the power m. Cos m theta plus I sin m theta. Okay. Now you take this one, you multiply by cos m theta minus I sin m theta. Then denominator going to be cos square m theta plus sin square m theta. Isn't it? Because I square is minus 1. When you multiply by cos m theta minus I sin m theta, this will be cos square m theta plus sin square m theta, this is 1. You can write cos m theta as cos of minus m theta, isn't it? So what have you got? Cos theta plus I sin theta to the power minus m is equal to this thing, cos of m theta plus I sin minus m theta. So therefore the theorem is true for a negative integer also. All right, it will be true for a rational number also. For irrational it is not true. Case 3, rational number you know of the form n equal to p by q, then pq are co-prime numbers and q greater than 0. So if we start with the expression, start with cos of p theta by q plus I sin p theta by q to the power q. Let us start with this. Q is integer, pq are co-primes, they are integer of course. So this gives us what? Cos p theta plus I sin p theta, isn't it? This angle, for this angle theta by q, if you multiply by theta, then it is going to be cos p theta plus I sin p theta. So therefore we can say that cos p theta by q I sin p theta by q cos p theta I sin p theta to the power 1 by q. Okay. So one of the root of this thing is here. One of the qth root of cos p theta plus I sin p theta is cos p theta by q plus I sin p theta by q. Now this cos p theta plus I sin p theta, p is an integer, is what? Cos theta plus I sin theta to the power p. Cos p theta plus I sin p theta is nothing but cos theta plus I sin theta to the power p. So that if you put on the right hand side, this is changing to the form what? Cos theta plus I sin theta to the power p whole thing to the power 1 by q, which is nothing but so much detailing is required when you start a topic. No, de Moivre's theorem is a topic in complex number. This detailing is required. That's why I explained that it will be true for positive integer, it will be true for negative integer, it will be true for irrational number also. Okay, proof is not required, but when you start something you need to know how does it come. Now I am going to show you some application of de Moivre's theorem. Okay, first application I will tell you why it was invented, to find the roots of 1. You know, square root of 1 is plus minus 1. Cube root of 1 also we have the experience. If x equal to cube root of 1, those are actually 1 omega omega square. For complex number in complex field we will find root. It is not square root only. Okay, it is actually complex number arise from the concept of equation. Otherwise root of square root of a quantity always positive. But when you are saying x equal to cube root of 1, then x cube is definitely 1. When you are saying x equal to square root of 1 in complex field, then it has come from a equation like this. That's why its solution will give you two values, plus minus 1. Its solution will give you x equal to 1 omega omega square. In real number, square root always positive, but here we will consider both. So to find the roots of 1, square root, cube root, no, we will find nth root. Then you can generalize it. See how to find it. So for that, let's start with the equation. Let x equal to nth root of 1. To find the nth roots. This implies x to the power n is 1. This is nothing but cos 0 plus I sin 0, not theta, this is 0. Now cos theta and sin theta, they have fundamental period, you know, 2 pi. In general, period of cos theta and sin theta is 2n pi. Okay? So you can add that on right side. So you can write or x to the power n equal to cos of 2k pi plus I sin 2k pi. K belongs to set of integers. Okay? So if k belongs to set of integers, then x to the power n is this. Now apply de Moivre's theorem. X going to be what? Cos 2k pi plus I sin 2k pi whole thing to the power 1 by n. Cos 2k pi by n plus I sin 2k pi by n. And this k actually, it can take the value from 0, 1, 2, 3 up to n minus 1. All n values it will take, and here we write xk in place of x. So the first root is what? x0. This is nothing but cos 0 plus I sin 0. That is 1. Second root is what? For n equal to 1, for k equal to 1, this is going to be cos 2 pi by n I sin 2 pi by n. x2 understand? So this way it will be continued. Cos 4 pi by n. I am writing the last one. Last one is x to n minus 1. This is nothing but cos k. K is up to n minus 1, no? So you write x n minus 1. Cos 2n minus 1 pi by n I sin 2n minus 1 pi by n. Okay? So these are all n roots of 1. You can write the concept of cube root from here. You can write the concept of 5th root, 7th root for all. Let me find another application of it. Suppose I want to find roots of the equation j to the power n plus 1 equal to 0. As it is, it will be a complex continuum. As it is a complex number, I am starting with z to the power n plus 1 equal to 0. Sorry, this is 0. How to solve this equation? You can answer this manner. Z to the power n is minus 1, which is nothing but cos pi plus I sin pi, you know. Period is what? 2k pi. So add over there. So this will be cos 2k pi plus pi I sin 2k pi plus pi. This without hesitation you can add in the angles because period of both is 2k pi. So z is going to be what? Cos 2k plus 1 pi I sin 2k plus 1 pi, this whole thing to the power 1 by n. So this is nothing but cos 2k plus 1 pi by n I sin 2k plus 1 pi by n. What are the values of k here? That k will be the same 0, 1, 2, 3 up to n minus 1. It has beautiful geometrical application also that I will discuss definitely, but wait for that. Know the application of de Moivre's theorem only. So it is used to find the root of an equation. Initially it was for that only, just to find the root. Then I am showing you few more applications to prove identity also. It plays a vital role. Okay, roots of unity. Then to prove identities, I am showing you some identities how to prove with the help of de Moivre's theorem, which is very difficult to prove by common calculation. Let me start with the easiest one. If x plus 1 by x equal to 2 cos theta, prove that x to the power n to cos n theta. This we are going to answer. How to? Is de Moivre's theorem straight? No, you can't, because it is x plus 1 by x. So what you have to do there, you start with the equation. You write the given equation. Given equation is x square plus 1 by x is equal to 2 cos theta. So x square plus 1 is 2x cos theta. So x square minus 2 cos theta into x. Now find x from here. 2 cos theta b square minus 4ac divided by 2a. Go on simplifying it. X will be, from here if you take minus 4 common, it is coming to be 2i into root over this by 2. Am I clear? If not clear, let me write it again. This you write plus minus, you take, yes, this will be 1 minus cos square theta. So it is, if you take, how have I got that? Let me explain. Minus 4 you take common, it will be 1 minus, so 2i, that's why coming out, and 1 minus cos square theta will be sin theta, that divided by 2. So x has a value cos theta plus I sin theta. X has another value cos theta minus I sin theta. Clear? So let us take any one of these. I am proving it here. For x equal to cos theta plus I sin theta, x to the power n, if you apply De Moivre's theorem, cos n theta plus I sin n theta, x to the power minus n, if you apply on it, cos minus n theta is cos n theta minus I sin n theta. By now we can write, if minus is there, here minus, both are positive. Because n will be replacing by minus n, cos of minus n theta is plus cos n theta, sin of minus n theta is minus sin I n theta. So to prove this thing, you just add these two, what you have got there. What you have got? Number 1 and this is number 2. Just by adding these two. Okay? So this way you can, even if you take cos x equal to cos theta minus I sin theta, it is better you show by that also. Cos n theta minus I sin n theta. Okay, what I am going to tell you, if you say that no, I don't understand, then I have to tell you. This thing to the power n is nothing but cos of minus theta I sin of so this is what? Cos of minus n theta. So this is nothing but cos n theta minus I sin n theta. Okay? So both the way you can prove. Then x to the power minus n will be what? By now we will remember this only. If n is there and minus sign is there, it will be simply cos n theta plus I sin n theta. X to the power minus n, how do you find? You can write one step here. Cos of n minus n theta. So on simplification, it gives us like this. Now this is 1 and this is 2. This is alternative method. We got the same thing. By adding, we can prove that x to the power n plus x to the power minus n is cos n theta, like that. Let us go for simplifying an expression like this. They have asked you to simplify this thing. Simplify cos I sin 5 theta to the power 2 cos 7 theta plus to the power minus 3 4 theta to the power 9 this to the power 5, given this way. You need to simplify it. Without using De Moivre's theorem, it will be very difficult. But by De Moivre's theorem, it's very easy. But before we apply this, I would like to remind you one product in De Moivre's theorem. That is what? Say there is cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2. If you open the bracket and take the similar terms, this can be written as cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. We have seen one example today also. This is what? If you expand it, I'll just show you. If you are, this is what, if you expand it, if you open the bracket, then this thing going to be cross, just multiply this by this, I sin theta 2 cos theta 1, I square is -1 minus sin theta 1 sin theta 2. Now take these two together, it will be cosine of this. Take these two together, it will be sine of this thing. Okay? So if you multiply these two numbers, result is this. This result can be extended for 3 numbers, for n numbers also, into after multiplication, this will give you theta 1 plus theta 2 up to theta n, I into it's okay, understand? This multiplication you can remember like this. For n angle, the addition takes place inside bracket only. This cos of theta 1 plus theta 2 this way, theta n, plus I sin of theta 1 theta 2 this way. So the concept of de Moivre's theorem together with this multiplication law can excel in solving problems from trigonometry, and wait, it has application in many fields. This is just one field I am discussing. Now what is the product here? If you apply de Moivre's theorem, or if you don't apply, then this we can write cos theta plus I sin theta to the power -5 into 2 minus 10. This one you can write I sin theta to the power 7 minus 3. Applying de Moivre's theorem in reverse, cos n theta plus I sin n theta is there. I am writing cos theta plus I sin theta to the power n. So this will be what? This is the advantage here. All are coming in the form of cos theta plus I sin theta. Hope you have understood.
Yes.
So there it will be -31, -5, -36, -36. Denominator also. Okay? Same, no? So it will be equal to 1. So fast it can be simplified. Now, apart from trigonometry, okay, do one more trigonometric sum. Yes, one more manipulative sum. Prove that cos theta plus I sin theta by 1 minus cos theta minus plus, these are skill based sum. Okay, just direct application of de Moivre's theorem. How to get this thing? This is a trigonometric identity. So to prove this, no rationalization. You just simplify it, writing this divided by 2 sine square theta by 2, this is just LHS, 2I sine theta by 2. So then you take 2 sine theta by 2 common, here also 2 sine theta by 2 common, what is remaining there? Clear? Understood? So this is, we cannot use de Moivre's theorem here. Why? Because it is for cos plus sine, not for sine plus cos. Then what to do? You write this one as cos pi by 2 minus theta by 2, I sine pi by 2 minus theta by 2. And here also the same manner. But before that, you just do one thing. Just do one thing. You can rationalize. If you like, you can rationalize. Now, so it is what? Rationalize? No, don't say rationalization. It just multiply by conjugate complex number. Into the same thing we are multiplying inner and here. This will be square. Sorry, this is cos. So sine square theta by 2 plus, we have multiplied by this, plus, hope you have understood the manipulation, isn't it? So I am changing this method now. If required, we will do later. So this is whole square. So use de Moivre's theorem. No, again you cannot use de Moivre's theorem. Cos theta by 2 you got, definitely, but you can't use de Moivre. This part is 1. So write that. Sine theta by 2, I cos theta by 2 to the power 2n, isn't it? So write this thing to the power n. Check once whether correct or wrong. Sine theta by 2. Yes. It is there. Just check whether it's coming this way or not. The thing you are going to prove this thing, no? Just check. This will be cos n pi minus n theta. It's my mistake. I wrote n pi minus n theta, and this is also n pi minus n theta. That's why I'm checking. Right side, little bit mistake was there in my writing. So this will be now apply to n because it is cos a plus I sin a. So use de Moivre's theorem. With 2n you multiply plus isn't it? So after this, let us do another type of sum. Sum is like this. If 1 plus x to the power n equal to a0, a1x, a2x square, then prove that a0 minus a2, a4 minus a6, 2 to the power n by 2 cos n pi by 4, and number 2 is a1 minus a3 plus a5 minus a7, 2 to the power n by 2 sin n pi by 4. It's a huge identity, no? It's identity in trigo. But we'll do it with the help of complex number. See how fast it can be done, how easily it can be done. First time you do it with me, next time you will be able to do it yourself. So in this relation, what is given? This thing is given. This thing is given. Just put x equal to I on two sides. Now 1 plus I is what? You can change into trigonometric form. Right side is what? A0, A1I. Next one is A3IQ. IQ is minus I. A4I to the power 4 plus. It continues this manner. Left hand side is what? This you multiply and divide by root 2. So cos pi by 4, isn't it? Because if you multiply by and divide by root 2, then this will be what? That only it. Root 2 to the power n, 2 to the power n by 2, cos n by 4, n pi by 4, I sin n pi by 4. So that you put here. Cos n pi by 4, left hand side. And how it is to I showed you there. I sin n pi by 4 equal to this thing plus okay. So cos n pi by 4 plus I sin n pi by 4 equal to this. Now you can compare. A0 minus A2 plus A4 minus this thing. Yes. No, I have taken I common from these. And these are all free. So this thing will be, oh, 2 to the power n. I forgot to write that. Extremely sorry, because here outside it is there 2 to the power n by 2. I forgot to write it. So this thing going to be 2 to the power n by 2 cos n pi by 4, and this part two to the power n by 2 sin n pi. Okay, done. Let us see this kind of thing also. Simplify. One more type. Simplify Just simplify. 1 plus I root 3 to the power 8. This thing to the power 8. Okay? How to? So go by that same trigonometric manipulation. This you write 2 into half plus and this also you write 2 into eight, isn't it? So this is going to be what? 2 to the power 8 I sine, not pi by 4, it is cos pi by 3 I sine pi by 3 to the power 8 plus this 8 will come here, cos 8 pi by 3 I sine 8 pi by 3 now these two getting cancelled. So what will you get? On simplification, these are repeated terms. 2 into 2 to the power 8 cos 8 pi by 3. Clear? Understood? Now they are asking another type of sum here. Find the value of this time it is not similar to previous one. 1 plus I to the power 1/3. This is not simplification. This is finding their same means we'll find cube root. Cube root of 1 plus I. So you put that x equal to so x cube is 1 plus I. This is what? Root 2 into cos pi by 4 plus I sin pi by 4. Okay. Now what is our next step? We add 2k pi with this. Isn't it? I sin, whenever you are finding root of an equation, 4th root, 5th root, 7th root, whatever, you follow this technique. Two to the power half into this thing. So x cube is this. X will be what? Use de Moivre's theorem. This divided by 3. I sin by divided by 3. What is the value of k? Because it is cube root, no? You are finding cube root. So k changing from 0, 1 up to 2. Clear? See, another type of sum, after this you will be able to solve most of it on your own. Just wait. I have collected the sum. We can solve it quickly. Just a minute. Suppose they have asked you to find the sum of this series The old IIT paper it is there. Evaluate or simplify sigma n equal to 1 to 10 sin 2n pi by 11 minus I cos 2n pi by 11. How to proceed? This thing actually partly dependent on the concept of Euler's theorem. Euler's theorem I haven't told you yet, but I am just briefly explaining. Then next class we'll be doing in details about it. Sin x series, if you write, it will be x minus up to infinity. Cos x series, if you write, x4 by factorial 4 up to infinity. And e to the power x series is what? X by factorial 1, this also up to infinity. So when you write cos x plus I sin x, then you can write up to infinity I into x minus this up to infinity. This we can write as 1 plus I into x. This minus x square by 2 we can write. And this we can write plus ix whole cube plus this way. This is nothing but e to the power ix. So now at this instant only we have proved that e to the power ix is cos x plus I sin x. This is called Euler's theorem. Next class we will solve sums based on these exclusively, but now we are going to apply this concept here together with the concept of de Moivre's theorem. See how to get it. This you can write as sigma n equal to 1 to 10, take minus I as common, cos 2n pi by 11 plus I sin 2n pi by 11. Take minus I outside. N equal to 1 to 10, it will be e to the power cos theta plus I sin theta is e to the power that e to the power I theta. We have proved it also. So now you go on putting n equal to 1. It is going to be e to the power 2 pi by 11i 4 pi by 11i six pi by 11i like this. This is still what? How many terms are there? Number of terms equal to 10. 10 terms are there. And they are forming a GP. This GP has common ratio how much? E to the power 2 pi by 11 I. Okay? So with that common ratio we can write the sum here. The first term into r to the power n minus 1 minus 1. 2 pi by 11 I minus 1. Now this is what? E to the power 20 pi by 11 I minus 1 isn't it? Now 20 pi by 11 is what? Two pi minus 2 pi by 11. So this is cos 2 pi by 11 only. Check once. This is going to be cos 2 pi by 11 only. So these two will be the same expression. They get cancelled. So answer will be this. Plus I sin 2 pi by 11. If you multiply by I, sin 2 pi by 11 I cos 2 pi by 11. Okay? Is that clear?
Yes, sir.
Now do the last sum from my side. Then your work will start. If xn equal to cos pi by 2 to the power n I sin pi by 2 to the power n, prove that x1, x2, x3 up to infinity the value is equal to minus 1. How to prove this? Yes, you just use the de Moivre's theorem for it. Just put it there, and that multiplication rule I told you. Cos theta 1 plus I sin theta 1, cos theta 2 plus I, they can be multiplied. So when you are multiplying, up to infinity, this is going to be for n equal to 1 pi by 2, for n equal to 2 pi by 4, for n equal to 3 continues this way up to infinity. Now we are multiplying, these angles will be added. Cos pi by 2, pi by 4, pi by 8. It's the infinite GP series. You can see that I into I sin of what? Those angles also to be added. Pi by 2 plus pi by 4 plus pi by 8. This way up to infinity. This bracket not required. So what do you get? Infinite GP sum you know, a by 1 minus r. R is half here. A by 1 minus r. So this is a by 1 minus r cos pi I sin pi. Cos pi is minus 1, sin pi is 0, so the answer is minus 1. Hope you have understood clearly what is de Moivre's theorem and how to apply it in solving